Okay, so let's solve this question. The question states that a list, basically this data type that has been defined, is basically used to implement a linked list, right? And this linked list is going to be given as follows, right? Okay, and what is the structure of a particular node of the linked list, right? So a linked list would have a pointer, right? This is the pointer, and a linked list would have a data, and this is the data. And data is of type integer. Very good, right? So they have, what they are mentioning, suppose that the program has created two linked lists. So L1 and L2 are two linked lists whose content are given in the figure below. Okay, code for creating L1 and L2 is not provided here. Fine. So this content is given over here for both of the linked lists. L1 contains 9 nodes, L2 contains 7 nodes, right? Very good. This data is given to us. Consider the following C program segment that modifies the list L1. Okay, so this L1 list is modified by the C program. Okay, the number of nodes that will be present in L1 after the execution of the code segment is, right? This blank over here specifies that this is a NAT type question. There are not going to be any options, basically numerical answer type question. Negative marking is not present in this, so you must attempt this question. And the basic assumption that was given to us was that L1 would have 0 to 9 number of nodes, and L1 is being manipulated, and L1 number of nodes that L1 is going to have after the execution, right? So that is the basic assumption. So I mean, I'm just saying to you, mark something from 0 to 9, right, if you don't have time, because attempting the question when there is no negative marking sometimes may hit you results, but obviously that is not a strategy, but that is a I mean, hope for the best kind of strategy. I'm just saying, just mark it something if you don't have time, but if you have time, obviously try to solve it, right? So they are given a function over here, this find function. What does this thing does? It is giving a query and it is giving a linked list, right, pointer. From this pointer, you're basically checking that if it is not null, right? This is the condition for your iteration of the loop that is present inside of this function. In this function, if the data of the node, the current node whose data is being basically changing, the node's pointer list is pointing to a particular node. Suppose that particular node, not from the end, from the starting, it's always better from the starting. So if I were to point it over here, this list, right? So this particular node, if its data is basically equals to the query, then return 1, right? It is basically found, right? That is, this find is basically the query that was given was that we have to find 1 in this linked list, right? If it was found, then we return 1, and if it was not found here, we basically iterate. This becomes 11, then it becomes 6, and so on and so forth, right? And if this list pointer gets still your null, then we are basically returning 0. This is the behavior of this find, and it works just as the word find would basically expect the function to behave, right? Find basically means that we are finding in the particular linked list, that is and what we are finding, this query that is basically provided. Very good, no doubt in this one, right? Now let's look at the second one. So this is the main function. The control is going to start from here, right? And we are basically defining two iterators. These two, L1 and L2, are basically the header pointers of these nodes, right? But we are defining two iterators, ptr1, ptr2, right? And we are checking the ptr1's next node, right? And if that is not equals to null, right? So this condition, this break condition, is actually very important, and this kind of break condition, if present inside of your any loop, that we are checking the next node at any particular time, then you must be very careful, because suppose the first node that is being considered, right, the first node that is being considered like this, its next is going to be checked, right? So suppose that your linked list has only one single node, right, and ptr1 pointed to this particular node. This while will break from the starting only, because its next is basically equals to null. It's not this not equals to null condition is not going to be met, and hence control is going to drop without analyzing anything, right? This is something that you must keep in your mind when you observe that the next node is being considered, right? Very clear, very obvious. Right over here in the L1, there are nodes present after the first node, so this is not going to break like that. And then what we are doing, we're taking the quantity, the next node's data, right? So the next node's data, is something that we are considering in the query, and then we're basically finding that next node's data in L2, right? So here 7 is going to be, we are going to take 7 and we are going to go to L2 with this 7 as query and try to find 7 in this particular linked list, right? As you can see, the first particular data 1 was not taken, 7 was taken. It is just the way the whole particular while loop, the whole code is arranged, right? And if you found 7 over here, then what we are doing, we are basically modifying the next pointer of the node that we are considering. That is, we are going to modify this particular pointer, right? And suppose this is the another node, so we are going to modify this, and what we are going to save in this, the next node's next, right? So we're basically going to modify it and point it to this. So this particular node is basically going to made to dangle and then forgotten, because there is no way to basically get to this node, right? Because its only occurrence, that was this, its only retrieval path was modified, right? And if this found did not work, then we did not delete, then we just basically iterate, go on iterating, right? Till we get to the till PTR becomes the last node. At that point, next is basically going to become null. Now observe this thing, this is very important. At the very end, when PTR1 is going to come at 8, we are not going to take 8 and basically send it into the whole L2, right? That is not going to happen, because its next is going to be null already. This 8 is going to be picked up when PTR1 is basically pointing to 15. That is the behavior. I do hope that you must be able to understand this part, because obviously this is kind of able to think in terms of steps, right? The current state is this, and then this is happening. Current state is this, and this is happening. This is kind of a thing which develops as you do programming and understand that yes, code only depends on this, and you are basically have practice to think in this manner, right? So this is kind of the whole thing which normal coding also requires, and this question also requires. So what all nodes are we going to take, whose data we are going to check in L2? These nodes. One we are not going to check, just as I showed you. Now 7, is 7 present in the second linked list? No, not really. 7 is not going to be affected. 12 is present. Yes, 12 is present. 3 is not present. 9 is present, right? 5 is not present. 11 is present. 15 is present, right? So all these nodes which were present in L2 are going to be deleted, right? And so how many nodes were there? 1, 2, 3, 4, right? 4 such nodes are which are going to be deleted, and total number of nodes were 9. So 9 minus 4, the nodes that we found that are to be deleted, is going to give us 5, right? So answer in this question is going to be equal to 5, and this is the whole of this question. 2-mark question, required a bit of analysis. Obviously there are silly mistakes that people can do, but obviously the question was good, right? As I have more time with the question than you do, I am going to give a small debugger demonstration. Not exactly going to run through every single step, but I am going to give you a peek into exactly when deletion was happening and what the result was from a data structure point of view, right? So this is the whole code, right? I have provided the segments which was not present in the question, right? They have basically missed this segments because they did not need that for the question to be framed, but this is required for the code to be run, right? So, and this particular statement is where the deletion was happening, right? This particular statement is where deletion was happening. This PTR was pointing to your first node. This node was pointing to another node like this, right? And it's next, that is this particular pointer, the data inside over here was modified, and what was stored in its place? The PTR's next, this is pointing to this particular pointer, and in its next is going to point to this particular pointer. So this address of this thing was basically put, and this part was made to dangle and forgotten, right? All these things was happening. So this particular statement was performing the deletion, right? So I'm going to show, and when control gets to this particular statement, then we can know that which node is being deleted, right? This is the list of the first, this is the list for the second, right? Linked list, and these are the common terms, right? See, the first one is also present in the common terms as written by me in a comment, but the control is not going to get to there, right? Let's run it, and we're going to observe it first hand. right? So PTR right now is pointing to what? It is pointing to 7, right? PTR is pointing to the node which has value 7. But remember that the node which is being pointed to is not the node which is being deleted. It's next part of that node that is being modified. So this particular node that is containing 12 is going to be deleted, and you can observe that 12 is present in common terms, right? So 12 is basically deleted. Very good. Now let's let it run to the next particular segment, right? So right now it is pointing to 3, but its next is pointing to 9, and 9 is present as the term which is it has to be deleted. Very good. Let it point to the next one. What does this thing point to now? This thing point to 11, right? So now 11 is going to be deleted, and 11 is also present over here. Now the next one is going to point to what? 15, right? So 15 is also deleted. Very good, wonderful. And mind you, one more thing. Right now the data over here is pointing to 5. You may think that before 5 there is 11 then 15, right? But 11 is already deleted. 11 is already deleted, and that is the very important part that you must focus, right? It's kind of thing about you thinking in terms of what is current state and what is the next state that is happening in terms of what code was actually executed, because this code is being executed. This iteration part is not happening, right? Very clear, very clearly understood. Now all the common parts have been deleted. If I were to press the next, I basically got till the end of the code, right? And this L1 points to the head of the particular linked list, right? So I'm going to give you the data visualization through means of software, right, of what was the end part. What was the end linked list that was given, that was left with us, right? This is the linked list which was left with us, and I'm basically pointing to you the answer from here, right? So from that, I do hope that you must have understood something, and you like the video, and and I will see you in the next one.